So this is the video for section 6.4, graphing sine and cosine functions. Now, when you get your notes and you look at them, you'll notice a set of instructions here. And the set of instructions are just telling you to find all of the sine values for all of your angles. Your 30-degree bow tie, your 30-degree angles with their reference angles right here, your 45-degree bow tie, and your 60-degree bow tie. And it's asking you then to find the quadrantal angles, 0, 90, whatever, and put them on this table of values. So I'm just going to go ahead and put them on the table of values very quickly and point, and then I'll be right back. Okay, so I filled in my table, and notice that anywhere I had a fraction, I converted it to a decimal. And it's an approximate decimal sometimes, like this is 0.70 something, but I just changed it to 0.7, and this was 0.86 something, so I changed it to 0.9. When you look at these, I want you to notice a pattern. The numbers, this actually is 0 also. Let's make sure we start with 0. It goes 0, 0.5, 0.7, 0.9, 1, 0.9, 0.7, 0.5, 0. Negative 0.5, 0.7, 0.9, negative 1, negative 0.9, negative 0.7, negative 0.5, 0. So it's a pattern. It's a flowing pattern. And if we were to plot these points on a graph, this is a graph from negative 90 to 360 with a scale of 30. Each tick mark is worth 30. And my y-axis goes from 0 to 1.5, 0 to negative 1.5, because this is a 1 right there. I know it's kind of small, but that's a 1. So I'm just going to plot my points, 0, 0, 30 degrees, 1/2, 45 degrees, 0.7, 60 degrees, 0.9, 90 degrees, 1, and so forth and so on. I'm just going to follow my pattern and plot my points. And I've done this a lot, so it's not something I expect you to be able to do this fast. I'm just used to drawing pictures pretty fast. I'm used to plotting points. When you look at it, remember I said that there was this flowing pattern. It rises to 1 and then it falls to 0, and then it falls to negative 1 and rises back to 0. This right here is the graph of y equals sine of x. This is the graph of y equals sine of x over one cycle. Now it starts at 0 and goes to 360. Now you know that we could keep going. We're allowed to continue to go to a 390-degree angle. And I want you to recognize that the pattern, the pattern just simply continues. And it would start to drop right there, okay? And on the left side, it would continue in the down manner so that we have a pattern right here. There is the pattern that would continue right there. And if you look at that shape, that kind of snaky looking shape is the graph of y equals sine of x. I also want you to see that the top line across there is a maximum value. It would never go any higher than that value. And this bottom line that I'm drawing right here is the minimum value. Now it comes back to that several times, but this is our minimum value. So our domain for this graph is all real numbers. I could go from negative infinity to positive infinity, but the range is from negative 1 to 1. I also want you to notice that some of these points were hard to plot. Some of these were kind of hard to find, but there were several that were very easy. And the easy points were any time it was on the midline, right here. Oh, by the way, this is called the midline. It has another name. We'll get to that in a second. The easy points were the ones that were on the midline and the ones that were at the maximum or the minimum. These points are easy to plot. Those are called your key points. And when you look at your key points and you say, all right, I've got a key point here, 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 and here. Notice it follows a pattern. Middle, up, middle, down, middle, up. The next one would be middle. Back here it went middle, so it went back to down, right? Down, middle, up, middle, down, middle, up. It kind of follows a pattern. Those key points, those key values are going to be what you're going to graph when you're creating graphs that you don't have specific points for. You're going to graph your midline, maximum, midline, minimum, midline, maximum, and so on. Looking at this graph, I want you to recognize there is an actual cycle to it. And the distance from one midline right here to this midline right there, that distance is called one period or one cycle. And you can repeat it. You can draw 1 period, 10 periods, 95 periods. But it's always going to look like this shape repeated over and over again. And that's y equals sine of x. Another thing I want you to recognize is how tall this graph is. How tall it is from the midline to the highest point matches how tall it is from the midline to the lowest point. And it continues to match that all the way through the graph. We can tell how tall the graph is by looking at the midline to the maximum and the midline to the minimum. And they always have to match, which is why this is called the midline. Another name for that line is sometimes called the sinusoidal axis. That's spelled S-I-N-U-S-O-I-D-A-L. Sinusoidal axis. You can slow this videotape down and watch it again. S-I-N-U-S-O-I-D-A-L. Sinusoidal axis. And that's the middle of the graph. If you look, I know it's in the middle because the distance to the high point and the distance to the low point matches. All right, I've already filled out the table for the cosine using the exact same process. And when I plot those points, I want you to notice that at 0, and it's the same scale, by the way, the graph is the same scale. At 0, I don't put it at 0, 0, I put my first point at 0, 1. And then I plot the rest of my points just like we did before. Going all the way to 360 degrees. And this one looks a little different. Look at the graph. I went from 0 to 360 degrees. Now, once again, this distance is 1 period. But notice this time, because 1 period was 360 degrees, but notice this time it did not go midline to midline, because midline to midline is only part of the graph. This went from maximum to maximum. And this is the cosine graph, which looks a little different from the sine graph. Remember, the sine graph started at 0, 0, but it's still the same basic shape. If I were to continue this graph like this, and continue this graph right here, you see the same basic shape. You see the sine curve right there, that this distance is 360 degrees, just like this distance is 360 degrees. In other words, the period length is the same period, it's just a different shift of it. It's like the original graph shifted to the right. It's like if somebody, or shifted actually to the left. If we started our original graph right here and we shifted it left 90 degrees, we would have had our sine curve. And that's because this shape, these graphs right here, both of these graphs kind of make the same shape if you look at them. They kind of make the same shape. That shape is called sinusoidal. And that's the reason we had that weird name for the middle line, sinusoidal axis. It's because all sinusoidals are the same basic shape. What is that basic shape? Well, there are 5 key points in each of them. We'll pick that up on the next video.